Good evening. First of all, I would like to thank you all organizing committee to provide me an opportunity to present our current research ongoing in our group. So I will go uh, uh, by one part. And that's the title of my presentation today is well-defined PN3P pincer manganese catalyst precursors, and this could be applied for the various type of applications like efficient and chemoselective hydrogenation of aldehydes, also as well as a reductive amination of aldehydes and homocoupling of amines to imines. So as most of us, we know that the uh, uh, carbonyl group reductions which provides the molecules which is alcohol, and most of the medicinal chemistry and as well as it's used as a synthon for many organic transformations. The best method to avoid any copious waste of amounts using the hydride reagents, boron and silane reagents, the most effective method to prepare of these alcohols is using hydrogens as a greener source of to reduce this most of the aldehydes into alcohol. And there are many manganese complexes as a cheap catalysis that could be used for the synthesis of these alcohols by directly using a reduction of these aldehydes. And most of this MN source that's we it is used as a pentacarbonyl manganese bromides. And if you'll see the total cost that we calculated, though it is very much higher than the precursors of this manganese to halide. So we think that uh, using this methodology, we use manganese 2 complexes, and we obtain the results that we are successfully reduces this aldehyde to various types of these alcohols, as well as we are successfully converted various type of feedstocks that such as furfural into the furfuryl alcohol. And we offer the year stable catalyst under mild reaction conditions that we use, and which is very highly selective for the only aldehyde. So for the preparation of this catalyst, uh, I will show you the preparation of this catalyst. It's very simple. We just prepare this bipyridine ligands and we mix it with the manganese source, and we obtain in under room temperature. We obtain this catalyst and we characterize it by the XRD. And this catalyst is very air stable. Within 6 months, it is under air, and if you put the reactions, it will work effectively. So using this catalyst, then further we carried out the various type of this alcohol which is undergoes the hydrogenations using 27 bar for pressure of hydrogen. And you can see the various type of this functionality is attached to this aldehyde was intact after the reduction, and various types of this aldehyde is undergo the reduction to provide so various type of this alcohol in good to excellent yield. Further, we also provided that the selectivity issues regarding when we use such type of this cinnamaldehyde, there is always possibility of the reduction of this carbon-carbon double bond as well as this carbonyl group. But here we observe that it is only selectively reduces the carbonyl group to alcohol. Even in case of this alkynes, we are successfully achieved the reductions of only the aldehyde group into alcohol group. And here you can see the various type of this aldehyde which containing a double bond as well as a triple bond is successfully achieved selectivity to reduce this aldehyde into this alcohol. Later on, we also studied that this methodology could apply for the various transformations of this furfural into furfuryl alcohol, as most of we know this is an important symptoms for various type of this industrial use as a feedstock for further conversions like gamma vaorolactone, and more often this is very important to use a pharmaceutical point of view. So we also by tuning the some reaction conditions in presence of methanol, we can successfully achieve the reduction of this furfural to furfuryl alcohol. When we use this 2-formate furfuryl alcohol, this is also the one kind of alcohol that is also in industry relevant value. So we also successfully achieved the reductions of this aldehyde moiety by selectively one carbonyl group get reduced when we change the pressure from 10 to 20. And further, if you want to reduce both two alcohol aldehyde groups, which can just use a high pressure of like 35 bar pressure, and that is selectively converted into this type of this alcohol selectively. Also, we achieve the more than 99% selectivity for these ones. So then we move that why this catalyst is applied for other transformations. As most of we know the imine, which is an important precursor of various type of drugs, which is observed currently. And the synthesis of this imine, there is many manganese source that they use, which is manganese 1, which is a very cost as compared to manganese 2. And they use coupling of this amine and alcohol to get the imine products. And also the one report, there is only one report where they use oxidative homocouplings of this amine to imine using this type of manganese class catalyst. Here we shown that the we achieve successfully a reductive amination of aldehydes and another one dehydrogenative homocoupling of this amine to imine product. And where here is we use ammonia as an amine source and hydrogen as a hydrogenations to actively directly form imine source instead of getting other reduction product of amines. So when we screen this catalyst using this benzaldehyde, and we found that the condition that we here screening conditions we use, and in presence of methanol and 120 degrees Celsius under these conditions, we oftenly observe that the yield of this imine is quite higher. So the traces amount of imine was also observed under these conditions, which is directly undergoes the homocoupling of this amine to imine products. So using this optimize the reaction conditions, then we try to study some substrate scope of this various type of aldehydes, which is directly converted into this various type of these imines in presence of ammonia as a source. And we achieve very excellent yield of directly homocoupling of this aldehyde into imine products. And you can see is here is the yield that we obtain is excellent to good yield under these conditions. Then we thought that we observed that the while we standardize the reaction conditions, the traces amount of amine, for example, see benzaldehyde to benzylamine. So we thought to use a benzylamine as a starting material, and only use a catalyst and the base. And we found that the this type of transformations where achieve imine product as a homocoupling products of these amines to imines. And you can see the various type of this substituents on aryl ring was intact under these conditions and provided this imine product with excellent yield. So to prove some mechanics investigations, we study some control experiments. And we thought that the in earlier case we observed that the direct the hydrogenation of aldehyde to provide this alcohol product. But in our case here is we started with this amine and we alcohol, and we use ammonia as a imine source, and we thought that maybe it will be coming benzylamine product. But here we didn't observe any kind of this benzylamine. It means the alcohol is not intermediate. Also we carried out the cross coupling reactions of using this one, like where we use this alcohol and you use amine. And we observe that it should be undergo in cross coupling reactions inside the during reaction. So we found that there is no any product form. It means this alcohol could be not the intermediate. Also we get the cross homocoupling of these two aldehydes together to form a cross coupling. This is an advantage for using various type of this two different aldehydes and to form a cross coupling to get a different kind of this amine product. So at this moment we are plausibly thinking the reactions mechanism. Still this work is under progress, and we think that this under the ammonia environment it could transform this aldehyde and under hydrogen environment, it reduces the imine, and this imine which further release one hydrogen atom to provide aldehyde, and the homocoupling of this imine and this amine and this imine to release ammonia and to provide this imine as a product. And uh, earlier we observed that this type of these transformations of this catalyst intermediate might be possible, although we are not successfully able to isolate those intermediates, but we were working on the DFT calculations to provide some strong support for our method. And in final, we conclusions. This is a conclusion that we obtained from this: the highly efficient redox-amination of aldehydes with ammonia and hydrogen into secondary amine, as well as the dehydrogenative homocoupling of benzylamines is described. So using a air stable and well-defined PN3 precursor manganese 2 complexes as a catalyst, various types of these aldehydes is easily converted into secondary amines using ammonia as a nitrogen source under hydrogen pressure in one pot. And more importantly, using the same catalyst, various benzylamines undergo the dehydrogenative coupling to form a imine product exclusively. Also, those all the reactions are conducted in very mild reaction conditions, and we don't add any other additives or any oxidant for to offer the imine as a product in excellent to higher yields. So this is all about my work, and thank you for your attention. And may I have any questions, I will happy to answer this. Thank you very much.